Hi, my name is Gary Horner and I'm currently a student at Full Sail University, taking video game design. For my Fundamentals of Physics class, my instructor, Thomas Oakson, asked us to take a principle of physics, demonstrate it, and then describe how this could be applied to our field of study. The principle I chose for this video is Pascal's principle for fluid dynamics. Pascal's principle states, a change in pressure at any point in an enclosed fluid at rest is transmitted undiminished to all points in the fluid. What this means is that the amount of pressure is constant as long as the fluid system is closed. Let's take this system for example. We have two reservoirs of fluid joined together by a tube between them. At this point in the simulation, the pressure on both sides is equal, and the plates at the top of the system are both level with each other due to the fact that their weight is evenly distributed and supported by equal fluid pressure underneath. Now let's say we were to increase the pressure on the reservoir on the right. Notice how the smaller reservoir on the left moves upward faster. This is because the amount of pressure has to be equal to the amount of force applied downward on the right side. The force is then applied to a smaller area, causing it to rise faster without requiring any more force on the right to move it. Now if we reverse the pressure, you'll see the opposite. As the plate on the left moves down, the larger plate on the right moves up at a slower pace. This is because even though there is equal pressure or force being applied to move the plate, it is spread out over a larger area. Now, as you can see here, once the closed system opens, the pressure is released and the plate on the right begins to fall. Now there are many applications of Pascal's principle in use in everyday life. Every time you take your car to the mechanic and it goes up on the lift, there's Pascal's principle at work. When you use a set of hydraulic brakes to stop a motorcycle, that's Pascal's principle at work there too. We run into Pascal's principle on a daily basis, and as such it's easy to see how it would be applied to a video game. The principle's effects are at work in the environments of most games you play. Pascal's principle would play very heavily into the mechanics and fine-tuning in a game such as Gran Turismo 5. Automobiles use Pascal's principle heavily in hydraulics throughout their design, and this game allows for high levels of customization of those hydraulic systems. The designers and programmers for this game will rely heavily on math to simulate Pascal's principle in-game. Now for this video, I wanted to demonstrate how this principle could be used in a video game puzzle. So, I've used my amazing abilities to create a virtual video game world. Well, okay, it's a floor plan, but we'll pretend it's amazing anyway. As your character walks into this room, what's noticed are boxes strewn about, a door in the wall that's just out of reach, and some circles on the floor. Now, as you explore the room, you stand on the larger of the two circles, and notice that it sinks into the floor just slightly. At the same time, the smaller concentric circles on the other side of the room rise at a slightly higher rate under the door. The solution to this room would be adding the correct amount of weight to the larger platform to cause the smaller platform to rise, allowing you access to the door and the wall. Physics is all around us and used in every aspect of our lives. Video games are no different. Every action in a game is dependent on a virtual rule representing a physical rule in the world that the game inhabits. Some of the rules in a game are modeled after the physical rules of our own universe, and some aren't. Either way, these rules need to make sense in the context of the game and also apply evenly. This would require a working knowledge of the rules in our own physical universe, even if we do bend them on occasion. Don't be afraid of science, because when it comes down to it, we're all science. Thanks for watching. Roll credits.